Lesson 5 is on mortgages. Most people who buy a home require a loan called a mortgage. So it's not very common that people would have, $200,000 or $300,000 to just buy a house. So a mortgage is similar to another loan, but it does take a really long time usually to pay off a mortgage. This is called the amortization period. So a typical amortization period might be 20 or 25 years that you would have this mortgage that you pay. For this reason, mortgages are negotiated for a specified amount of time called the term of the mortgage. There's typical terms might be 3 or 5 years. So what that means is that after that 5 years is up, you would maybe need to go back into the bank and renegotiate another term for the next 5 years of your mortgage, just because interest rates can really change over time. So it might be your advantage if interest rates go down, that you could negotiate a lower interest rate, or if interest rates go up, then the bank is going to expect you to be paying a higher interest rate just because the mortgage is for such a long time. So Canadian law requires that mortgage interest rates be compounded semi-annually. But what's interesting about that is that most of us pay our mortgage monthly or bi-weekly, just as, every 2 weeks if you get paid. So we are going to have a different compounding period compared to our payment schedule when we look at mortgages. So what we're going to do, and we'll practice a few of these, converting a semi-annual rate to a monthly rate. So for example, if you're told that a mortgage rate is 4%, that means it's 4% semi-annually. So 4% divided by twice a year would be 0.02. Okay, so using a monthly interest rate I, $1 is going to grow. If this was monthly, our exponent would be 12. 12 times in 1 year. When it's semi-annually, our exponent is 2. So we need to make sure that these two amounts are actually equal to each other. So this is when our mortgage interest rate is 4%, semi-annually. So what we're going to do is we're going to take this 1 plus I to the 12th. And what we need to really know is, what would this I be if this was compounded, if the interest was compounded 12 times a year? On this side, we do 1 plus our I, which is 0.02 if it's 4%, to the exponent 2 because it's semi-annually. So one thing to do, if you have an exponent of 12, if I took the 12th root of that side and the 12th root on this side, then I'm allowed to do that, because whatever you do to one side, you have to do to the other. But what would happen is that 12th root of something to the 12th, they would cancel out, and then I would just have 1 plus I. On this side, though, the 12th root, another way for that to be written would be 1 over 12. So if I didn't write the 12th root, I could write it as a fractional exponent, 1 over 12. So that's what this is here. And then I can multiply my exponents together and get 2/12, which is the same thing as 1/6. Let's practice that. Because we buy a house and we get a mortgage at the beginning, we're going to still use the present value formula. So example 1, Mr. Burns buys a home. He needs a mortgage of $215,000. The bank offers Mr. Burns a 20-year mortgage. Okay, 20 years, that's good. You'd pay less interest that way than opposed to if it was 25 years. And they offer him 5.5% interest. But he's going to make bi-weekly payments. Okay, bi-weekly payments, that's every 2 weeks. There's actually 26 payments in a year. There's not 24, there's extra days in each month, so we end up with 26 payments per year. What is the bi-weekly payment? So this 5.5%, we know because it's a mortgage, that is semi-annual. That's different. Something else we can see is if there are N for our formula eventually, we have 26 payments a year, and he's paying this in 20 years. So in total, Mr. Burns has 520 payments. So this 5.5% was semi-annually. So we're going to have to take our interest, and we know that that's 0.055 and divide it by 2. So our I we're going to use, if it was semi-annually, 0.0275. Okay, but there is a problem here. We know that that's our semi-annual interest rate, but it doesn't match 26 payments per year, which is biweekly. So what we have to do is first find out what the interest rate would be for the biweekly payments. So I usually will do a little chart on the side. Biweekly has to equal semi-annually. Our biweekly we know is 1 plus I to the exponent 26 because we have 26 of those payments. That has to equal 1 plus 0.0275 to the exponent 2, because that was our semi-annually. Those two terms have to equal each other. So one thing that we can do, we can take, in order to remove this 26, we can take the 26th root of this side, 1 plus I to 26, so that those would cancel each other out. That means on this side, we actually have to take the 26th root of 1.0275 to the exponent 2. What that means is, on this side, since these cancel out, I just have 1 plus I. But on the right-hand side, what I could do with this 26, I could write this as 0.0275 to the 2 over 26. Is that 26 written as a fraction? And then the denominator is the same thing as the 26 written as a root out front. So one last thing I could do there, anytime I see a 1 plus I in my formula, instead I'm going to use 1.0275. I could simplify this fraction, which would be a good idea, to the 1 over 13. So this is what we're going to use here every time we see 1 plus I in our formula. So our present value formula, we know though that the present value of the house that he's going to buy is $215,000. We're trying to find his biweekly payment. So anytime I see this 1 plus I, I'm going to write this instead. So right in there, I'm going to write 1.0275 to the 1/13th. And then my n, we already found what that was before. It was 520 to negative exponent negative 520. And all of that is going to be divided by I. Okay, there's a problem there though. This is what 1 plus I is. So just I would do the 1.0275 to the 1/13th, and I'd subtract 1 from that. Because this is 1 plus I. If I just want the I could move the 1 to the other side, and that's what I would have for my value of I. Now, one thing that I do right away, I want to get rid of this denominator so I could multiply both sides by what I see in the denominator. Multiplying on this side, they'd cancel out. So really, I just have to multiply this side. I would find 1.0275 to the exponent. When you do exponents with fractions, you might go to the exponent bracket, 1 divided by 13 bracket equals minus 1 equals, and then times this number. So I'm trying to cut down on the amount of numbers that you have to write down. But just to show you, I'm using lots of decimal places. You don't have to write all of this down. You can do more of it in one step. Okay. And now on the right-hand side, I still have R because I don't know what the payment is. And I can do 1 minus, I could do all of this here. So if I look at 1.0275, I can multiply my exponent. So 520, negative 520 times 1 is negative 520, but then I divide it by 13, so I get the exponent of negative 40, which looks a lot easier. And I don't have a fraction. So now I can use that again. Now I can actually find what this is. I would type 1.0275 to the exponent negative 40 equals, and I'd probably do 1 minus my answer. Remember before I told you about that A and S button? If you have that on your calculator, it makes it really nice. 1 minus my answer. So I find inside the brackets I have 0.6621477779. And then I would have to divide both sides by that so that they cancel out on this side. And then I would have my regular bi-weekly payment. When I divide is $678.30. So therefore, the bi-weekly payment is $678.30. What I find really interesting is the next part. Calculate the total interest paid on the mortgage. Okay, so total paid. Mr. Burns had payments of $678.30, 520 times, so 26 times a year for 20 years. We figured out that he would actually have 520 payments. So he actually paid $352,716 for his house. But remember, this is a pretty typical mortgage, so I want you to really see this. The interest, he paid $352,716 for this house, but the original purchase price of the house was only $215,000. So when I subtract those, I actually get the interest that he paid to the bank, and you might be shocked to see in 20 years it was $137,716. So that is the interest. So you might think, well, the house was only $215,000, and then this is how much interest he paid the bank. And that is a typical mortgage. It's very sad because this is money that you've kind of just given away in order to get the loan to buy the house. And then last part, how much is still owing on the mortgage after the first 3 years? So we need to find the present value of the remaining payments for 3 years. So 3 years, that means he would have paid for 3 years, 26 times a year. He would have already made 78 payments. There were 520 altogether. If I take away the 78, he has 442 remaining payments. We already know that his payments are $678.30 a month. Or no, sorry, every 2 weeks. And then we already know the 1 plus I is 1.0275 to the 1/13th. But he still has 442 payments left. And then we divide that by I. So that's 1.0275 to the 1/13th minus 1. So now it's just about calculating this to find out what he still owes after 3 years. So $678.30. In here, I would probably see the fraction, 1.0275. I would multiply the numerator, so negative 442, and then divide it by 13, and I get negative 34. Divided by 1.0275 to the 1/13th minus 1. So honestly, your scientific calculator can do a lot of this for you in one step because nobody really wants to write down all of those decimals, right? Like this is me just trying to explain how to get the answer. I would love it if you tried to do this in less steps and let your calculator see if you can get $195,608.32. So that is what he still owes on the mortgage after 3 years.